In this video, we're going to be talking about rational operations. In order to do this, I'm going to start with a basic example. 1/2 plus 1/6. In order to add these two together, I want to find a common denominator. And in order to do this, my common denominator is going to be what's called my least common multiple. In this case, between 2 and 6, my least common multiple would be 6. So I'm going to multiply my first fraction by 3 over 3, which would give me the fraction 3 over 6, which when I reduce 3 over 6, I would also get 1/2, so that's a way to check. Now that my denominators are the same, I can add the numerators across and then simplify or reduce, and I'm left with the sum of these two fractions. So now let's start with an actual rational function. Given 3 over x plus 1/2, I would try to find a common denominator using the least common multiple. In this case is going to be 2x, so I can multiply this first fraction by 2 over 2 and this second fraction by x over x, giving me the new expression 6 over 2x plus x over 2x. The denominators are the same, and I can add across. 6 plus x divided by 2x. After this, I want to make sure I simplify. And to simplify this, you would look to see if you could factor anything out from the numerator, and then look to see if you could factor anything out from the denominator, and then attempt to cancel. In this case, I cannot. And so I'm left with 6 plus x divided by 2x. Now let's look at subtraction. For subtraction and addition, we want to make sure we have the same denominator or common denominator using my least common multiple. So for subtraction, let's say we have 3 divided by x plus 2 minus 1 divided by x. The least common multiple here is going to be x times x plus 2. So I want to multiply my first fraction by x over x and multiply my second fraction by x plus 2 over x plus 2. From here, I would get the new expression 3x divided by x squared plus 2x. We want to make sure that we are distributing, minus x plus 2 divided by x squared plus 2x. Once again, I have the same denominator, so I can subtract the numerator straight across. 3x minus 2 plus, or minus x plus 2. When we do this, we want to make sure that we distribute our subtraction sign to both terms, and then we would simplify, getting 2x minus 2 divided by x squared plus 2x. I want to factor out a 2 in the numerator, and then factor out an x in the denominator. And I do this so that I can check to see if I can cancel any factors out and simplify further. In this case, I cannot. So, from here, let's move on to multiplication. So with multiplication and then later with division, we don't have to worry about that common denominator. So let's look at a generic example. 1/2 times 1/6. In this case, I multiply numerator and denominator straight across. So 1 times 1 is 1, 6 times 2 is 12. So now let's look at a more complex example. 12a divided by 10 times 10 divided by a minus 7. So from here, I'm just going to multiply straight across. Now notice when I multiply straight across, I'm going to leave it as a list of factors, because when I get down to this step, I can see that I'll be able to cancel out a few terms. So this 10 in the numerator and 10 in the denominator will cancel, leaving me with a 12a divided by a minus 7. So now let's look at another one. 9r plus 72 divided by 9 times a 7 divided by r plus 8. Once again, I'm just going to multiply straight across, but I'm going to write it as a list of factors. Now notice here it gets a little more complicated because there's a few things we can factor. So looking at 9r plus 72, I can factor out a 9 from both terms, leaving me with r plus 8. And notice that the r plus 8 factors will cancel and the 9 over 9 will cancel, leaving me with 7. So finally, our last one, or last operation, is division. So a basic example, 1/2 divided by 1/6 is going to be the same as saying 1/2 times 6 over 1. Because when we're doing a dividing up fractions, our second fraction we're dividing by, we can flip it to solve this and then turn it into multiplication. Which when I multiply straight across, I get 6 over 2, leaving me with 3. So a more complicated example of this would be 6a plus 60 divided by a minus 4 divided by 6a plus 60 divided by 6. So from here, just like in this first example, I can flip the fraction I'm dividing by, where I will rewrite it as 6 divided by 6a plus 60. And when I do this, we should be able to see that I'll be able to cancel out 6a plus 60 since it appears both in the numerator and denominator, leaving me with 6 divided by a minus 4. Thanks for watching.